Okay. On the first graph, so front side, left side, we're first just going to graph, sorry, you can't see this part. There we go. We're first just going to graph the parent function. So remember, what is a parent function? Simplest form of it, no transformations. Okay? So the parent function, we'll build a table for it here. The vertex of a quadratic we would expect to be at 0, 0, kind of the turnaround point. When we plug numbers in around that, we see that with our quadratic, negative numbers get squared, but will be positive now, and positive numbers are squared and still positive. So we should see these points for our quadratic. Is that okay? So the parent function, again, is the simplest one, so it doesn't take much to get it drawn. And then we're going to go through each thing that's on that list that we should be able to identify from the function. So the first thing is the vertex coming from H and K. So there's two ways to see this. One is you should be able to see the vertex on the graph. The second thing is if you think of this as ax minus h squared plus k, h would be added or subtracted to x inside what's being squared, and k would be after. And just like with our absolute value, we don't see anything being added here or after, so our vertex would be at 0, 0. Our x-intercept would be what? 0, 0 is where it's hitting the x-axis. And y-intercept? 0, 0. It's very interesting right now, right? All right, domain. Good. All real numbers or negative infinity to infinity. So two reasons. Visually on the graph, we can see that any x value we select from left to right would correspond to some point on the graph. So there's no x value that excluded. Algebraically, you can see that anything you plug in here, you're capable of squaring. If you put it into a calculator and you square it, it would be able to give you an answer. Okay, it wouldn't be something that it couldn't calculate. So our domain is all real numbers, or from negative infinity to infinity. What about the range? Good. Y is greater than or equal to 0 or from 0 to infinity. And again, in our inequality, we would say it's greater than or equal to 0, which means in our interval, when we say from 0 to infinity, we are including that 0 value. All right, increasing interval. So when we look across the graph, what do you think would be our increasing interval, Brandon? Good. So remember that increasing interval is not telling me the y's of how high or low the graph is going. It's saying as you read it, you would first be going downward, so you would call this part of the graph decreasing. Then you'd hit this point at 0, and then you'd be going upward, so you would call that part of the graph increasing. And remember, you're listing the x's for when that's happening. So from negative infinity to 0, our graph would be in the decreasing category. And then from x's that are from 0 to infinity, our graph would be called increasing. So our increasing intervals from 0 to infinity. And remember, we use parentheses for both of these because 0 is like a point where you're not part of the increasing or decreasing. You're not going uphill or downhill for like one moment. So we just don't categorize it as either. And then our decreasing interval would be that negative infinity to 0. Is the graph 1 to 1? No. So it's a function, right? But it doesn't meet that extra requirement of being 1 to 1.
Any function?
Yes, there are some that we'll come across, but this one is an absolute value is not, and both kind of for the same reason, right? For rate of change right now, we're going to leave it blank, and we'll come back and talk about it later in our course, okay? So you won't have to worry about putting that in. Good, our axis of symmetry is at 0, but we need to name it properly. It is a vertical line through our graph at 0, so x is equal to 0. Minimum value? What is the smallest y value that this graph hits? 0. maximum value? Since it goes to infinity, we say it has no maximum value. None. Okay? Because a value has to be one specific numerical value. Okay? That's not what infinity is. And then for asymptotes now, again, kind of like the rate of change. You're just going to write none for now. We'll talk about them more when we see something that actually has an asymptote. Okay? Again, the place you guys did see that in Algebra 1 was exponential functions. Now, no, I have one more page. There's like 4 pages. So I've done 3 of the 4, but I haven't done the 4th page. So they'll be recorded tonight. You can see it, and then you'll get to look at them tomorrow. Okay? All right. Are we good with this part? Yes? Okay. So then tomorrow, we'll save the next part for tomorrow because we have like 5 minutes. Yes? Rate of change for your quiz you should have had because we did do it for absolute value and slope was fine to put. Why can't I just write 1 here as the rate of change? Natalie? Good, it changes. It's not linear. So in this case, I go over 1, but I go up 1. The next time I go over 1, I'm going up 3 more from the place I was at before, or 4 total from the beginning. So now we're leaving out rate of change for a specific purpose. For asymptotes, you guys didn't have to worry, so no matter what, you're fine. Okay? For what? Yeah, that's why we're leaving it blank right now. There's like a calculus way to write it, and then there's like a depending if you're not thinking that far ahead. So I'm going to talk a little more to the pre-calculus teachers about how much they'd really like you guys to know, and they might say nothing, wait till we get to the place where it's proper to discuss it, or they might say, mention it like this to them. In regular algebra 2, they will write like varies. Right. So that's, again, our course is a little different, and we don't get to just kind of leave it that unsaid. We're either not going to discuss it now, or we are, but we're not just going to write varies, because later on you're going to find a very specific way to do this. The rate of change is actually 2x, if any of you care. Very random why that's the rate of change. But no, for this particular function. Different for other functions.
2 is the answer to everything.
No, not. But are we okay so far with this? So the 2 other graphs on your paper, let me just mention this. This next graph right here, we're going to graph with transformations. And this is an Algebra 2 level question. Algebra 2 will do this as well. Not right now. Later. The one on the back is extra because you took this class and you're so excited about it. Okay? The one on the back is what we're expected to do here that Algebra 2 students wouldn't do until pre-calculus, all because of this 1/3 in front of the x right here. Okay? And how that affects the graph, which is different than how this 2 outside of those parentheses affects the graph. And it's something they do not discuss in regular Algebra 2. But we do, because you're skipping a whole bunch of pre-calc by taking this class, so we teach it in here. Congratulations. Is it what? Did you say? Is it what? Oh, okay. Yeah. All right, we do have a birthday today. There isn't any homework tonight. Your weekly reviews are due on Thursday, so if you want to do those tonight. If you had trouble with transformations, but you talked to someone today and you feel a little better, you could go back and do that. I know, what? That's what I would say too if I didn't have any homework. But you do have you have 2 things that you're going to be working on tomorrow night. Tomorrow night you're going to have the second homework from this unit, but then you're also going to have what else? The little video links are due tomorrow by midnight. So if you want to go do that tonight, you could do that. So all that means is if you're selling tables and chairs, you put little links to YouTube videos that are like advertisements for table and chairs, or you make your own. Okay, I don't know. All right, our birthday is for Kaylin. Happy birthday, Kaylin. Today's her actual birthday. I don't know. That's up to you guys. I'm not big in the realm of scene. Oh, look at all these people.